Alright, so what are disaccharides, guys? Well, disaccharides are simply made up of, these are carbohydrates, yes, but they are made up of two sugar units. Unlike monosaccharides, which are made up of single sugar units, disaccharides are made up of two sugar units. Okay, and these, they are crystalline in nature, they are sweet to taste, and they readily dissolve in water. Okay, they form those crystals, right? Just like sugar. Yeah. You know sugar, you know what I'm talking about. So they are formed by the condensation, okay, which is also known as the dehydration reaction between two monosaccharides, which are joined together through a glycosidic bond. For example, when you get two glucose sugars, you combine them via a condensation or dehydration reaction, you come up with a disaccharide. Okay, yeah, because you would have in total have you would have two sugar units in total, right? Yes. So these simply temporary energy storage molecules. Why? Because they are broken down by hydrolysis into their different monomers, which are then used to produce energy through cellular respiration. So once they are introduced to water, then they are separated. Okay. Well, the most common types of disaccharides that we are going to talk about in this video are sucrose, lactose, and maltose. Okay, we've got sucrose. So we're going to talk about sucrose, lactose, and maltose. Right, but because of the name that I came up with, I'm going to start with maltose, sucrose, and lactose. Okay, yes guys, okay. So if you want, you can make use of this name. Okay, so from maltose you get this part, from sucrose you get this part, from lactose you get this part again. Okay, so the first two letters you get them, then you come up with this. Okay, all right. So what are these? What is this, guys? What is this? What's the name? The name is masula. Masula is the name, guys. Okay, masula is the name, guys. Okay, so masula is the name. So from masula, everything will come from there. Yeah, everything come from masula. How? Well, here's the thing. So masula, right? Yes. Then we also have got this one. Okay, so it will be like this. So this masura, yeah, is somewhere there. Okay, so this is ggf. Okay, go fresher. yeah, but this first one is glucose, this one is galactose, This one is fructose. Okay, this one is maltose, sucrose, and lactose. We know that maltose, sucrose, and lactose come from these single glucose, single sugar units, right? Which can be glucose, galactose, and fructose. Okay, so now these are single sugar units. These are two sugar units. Okay, for example, how is maltose formed? Well, for maltose, you simply get two glucose units for maltose, right? And these are the alpha glucose. Okay, yes. What about for sucrose? What about for sucrose? Well, for sucrose, you get one glucose and one fructose. And these, so for maltose, they are connected via a 1 to 4. These are, excuse me guys. So these are connected via a 1 to 4 alpha glycosidic bond. So these they have gotten alpha 1 to 4 glycosidic bond. Okay, yes. Well, what about for this one? So for this one, it is made up of one glucose unit and one fructose unit, right? And it is connected via a 1 to 2 glycosidic bond. Okay, 1 to 2 glycosidic bond. All right, but the same 1 to 2 simply means that you have the alpha glucose and the beta fructose. Okay, so this is this sucrose is made up of alpha glucose and beta fructose, which are connected via a 1 to 2 glycosidic bond. Well, what about for lactose? Lactose, it is made up of glucose and galactose. Okay, they will form something like a triangle here. Okay, so this one is made up of glucose and galactose. So for this one, we've said, so the first part is made up of alpha glucose, just alpha glucose, 2 alpha glucose. For this one is made up of, so for this one, it is made up of alpha glucose plus beta fructose. Okay, which are connected. Okay, which are connected through a 1 2. Okay, yeah, 1 2 glycosidic bond. Alright, so even this one you can just put a comma, it's fine, still fine. Okay, yes guys. Well, what about for this one? So for this one, this is lactose, which is made up of glucose and galactose. Yes, but what type of glucose? Well, for this one, it is made up of either, okay, this one is optional, right? You can either have alpha glucose or beta glucose. Okay, yeah, alpha glucose or beta glucose. All right, but so for glucose it is optional. So this one, yeah. Then it is composed of a 1 to 4 glycosidic bond. Okay, so it is made up of alpha or beta glucose. Okay, plus beta galactose. Right, guys? Yes, that's the thing. Okay, but let's also take note of some things here. Okay, yeah, we need to take note of some things. So this is made up of one. So this is a 1 to 4 glycosidic bond between carbon 1 of alpha glucose and carbon 4 of alpha glucose. Again, another alpha glucose. For this one, which is sucrose. Okay, for sucrose, guys, it is simply made up of carbon 1 is from beta galactose. Okay, yeah, so we are talking about sucrose, right? Yes. So for sucrose, the carbon 1, this one simply means carbon, right? Carbon, right? Even this one simply means carbon. So this one happens between carbon 1 of alpha glucose and carbon 2 of beta fructose. Okay, but for this one, guys, don't say that this one happens between carbon 1 of either alpha or beta glucose. No, right? But rather this one happens between carbon 1 of beta galactose and carbon 4 of either alpha or beta glucose. That is it about lactose. Okay, yeah. All right, guys. So this is it about disaccharides. Yeah, this is it about disaccharides. I think with that in mind, we can now simply start looking at each one of these. Okay, in this case, we start with maltose. Okay, so let's simply start with maltose. So we'll start with maltose, but everything we've discussed them here. So we're starting with maltose. Okay, amazing. So now for maltose, okay, yeah, maltose is soluble in water. Okay, yeah, maltose is soluble in water, and it is composed of two glucose molecules which are linked through an alpha 1 to 4 glycosidic bond. Okay, or linkage. Yeah, so this one is also a reducing sugar, okay, because carbon one on one of its glucose monomers is free and can form an open chain to expose the aldehyde, which has the reducing properties. Okay, yeah. So now let's draw the structure. Okay, let's draw the structure of maltose. Okay, how is maltose formed? Right, guys, how is maltose formed? Well, we say that maltose is formed between two what? Two glucose, two glucose units. So we'll draw two glucose. Okay, so we need to be familiar with monosaccharides. Monosaccharides are very important because they are the building blocks of disaccharides, even polysaccharides, right? Oligosaccharides, all those. So this one will react with another one. Okay, and this is a reversible reaction to form what? To form this. Alright, guys, so well, since this is an alpha glucose, so the OH will be down there. As you can see, here you have got the oxygen. Okay, right. So these are two glucose units, right? So when these combine, right, and under the process called dehydration or condensation reaction, okay, whereby um there will be a removal of a water molecule. That's the reason why you can see a negative here. Okay, what will simply form is maltose. Okay, so as you can see, this is carbon 1 2 3 4, right? So this is carbon 4, right? When you start counting 1 2 3, so this is 1 and this is carbon 4. So this forms between, and these are both alpha glucose, right? Because as you can see, the OH group is down on carbon 1, and even here the OH group is down here on carbon number 1, right? Yes. So now the idea is these two will react. Okay, these two, this one and this one will react. Okay, so when these react, they'll form water will be formed and removed. Okay, so what simply happens is as you can see, how many hydrogens do we have? We have got two hydrogens, right? Yeah, so I've got two hydrogens, so all of them will get them, right? What about oxygen? How many oxygen do we have? I've got two oxygen, right? So for us to form water, you only need one oxygen. And what about the other one? Where is it going to go? This is the one we have here. Okay, and this is what we call an alpha. Why alpha? Because it is from alpha glucose. Both are alpha glucose, so it will be called the alpha 1 to 4. 1 to 4, why? Because it is being formed between carbon 1 and carbon 4, right? So it will be alpha 1,4 glycosidic bond. Okay, so this is a reversible reaction. When you add water to it, okay, when you add water under a process called hydrolysis, okay, which is simply the breakdown. Okay, so when you add water to maltose, it will go back to what? To its single glucose unit. All right, so this is it about maltose. Okay, so the idea is you need to understand the monosaccharides, grasp monosaccharides, then it will be very simple for you to come up with the structure of disaccharides, oligosaccharides, even polysaccharides. All right, guys, hope we are together on that one. So this is simply the structure showing the formation and breakdown of maltose. This is how maltose is formed and broken down. With that said, we now move to sucrose, guys. Let's move to sucrose.